The balancing point in a meter bridge is at 35.6 centimeter. If the resistances in the gaps are interchanged, then the new balancing point will be. So we have a meter bridge over here, and the length of the wire connecting point A and B is 1 meter, that is equal to 100 centimeter. And as you can see, there are two different resistors R1 and R2 connected in left gap and right gap of this meter bridge. You might have done this experiment in your classes that after closing this key, you keep on putting this jockey onto the different position of this wire, and we try to find out null deflection in this galvanometer. And as soon as we get the null deflection in this galvanometer, we stop sliding the jockey onto this wire. That point is called as null point, and this length is called as balancing length. And we all know that the meter bridge works on the principle of Wheatstone bridge. If we say that the current flowing through this middle branch is 0, that is the deflection in this galvanometer is 0, then the bridge will be under balanced condition, and that condition is given by the ratio of these two resistances, that is R1 and R2, exactly equals to ratio of these two resistances, that is R3 upon R4, R3 upon R4. So let us use this idea to solve our question. So in the question it is given that the balancing length of this meter bridge is 35.6 centimeter. As we all know, the length of this wire is 100 centimeter. So the remaining length will be 100 minus 35.6, that is 64.4 centimeter. Now let us assume that the resistance of this complete wire is K ohm per centimeter. Then the resistance of this portion becomes K times this value, and the resistance of this portion becomes K times this value. And as discussed in the previous slide, that if the deflection in the galvanometer is 0, then the ratio of this R1 and this resistance must be equal to the ratio of this R2 and this resistance. So let us write that equation here. R1 upon the resistance of this wire, that is 35.6 multiplied by this K, must be equal to this R2 upon resistance of this wire, that is 64.4 into K. So if you simplify this equation, you will get R1 upon R2 as this value. Now in the question they are saying that if R1 and R2 are interchanged, then what is the new balancing length? So let us interchange these two resistances. This is R2 and this is R1. So in that case, let us say the balancing length is somewhere over here. Let me draw the jockey. This is the balancing point. And let us say this length is L centimeter, then the remaining length will be 100 minus L centimeter. So again, if we use that Wheatstone bridge idea, then we can write R2 upon resistance of this part, that is L into K, is equal to R1 upon resistance of this portion, that is R1 upon 100 minus L into K. Now from here, if I find R1 upon R2, then I will get this expression. Now call this equation number 1 and equation number 2. After simplifying equation 1 and 2, you will get L value as 64.4 centimeter. So the balancing length in the new case is 64.4 centimeter.